Alrighty. Alrighty indeed. Let's see here. Just gotta spend a little time. And we're live. Good morning, everybody. I'm Alex. We're back at it. Some fun video game programming stuff, as we are every morning, every night. And, if you want to, you don't have to, but it'd be nice if we all did it together. We could theoretically go get our morning teas and coffees and, whatever else we drink. I could count us off, 3, 2, 1, and then I'll take a sip. Something like that. And, I actually did pretty good today. That is actually pretty good for the last little serving of matcha from the jar. I think I got some good foam on that there. Okay, so today, I spent a little bit of time last night working this same sort of like render synchronization problem. And as you can see, I moved us off of display link, off of CA display link, because that was kind of controlling our controlling the rate at which everything was moving to a pretty high degree. It was basically forcing us to VSync, and you'll see even here, still sometimes something is trying to enforce VSync, even though we've kind of moved to a more generic layer. So now everything, our render loop is just a function, or is just a method owned by the view delegate or property, whatever it is. It's a method. It's owned by the view delegate. That is just calling our game loop and render pipeline construction, right? And that actually probably should be there. If that makes sense. Probably should be there, maybe. Because we want to bail out kind of as quickly as we can. But I think the problem... Ooh, yeah, my computer is already starting to... Fans go on. So I think we are... we're definitely using a lot more of the CPU to do stuff. We're pushing so much more through. Oh, look, this crashed. But our utilization graph in here has been way spikier than, and more constantly spiky than it was back when we were using display link. Display link, we would see spikes show up every, periodically whenever a new frame we thought was getting called. It's kind of hard to tell because everything is moving so fast here. But also this crashing is not good. that's kind of not great. And it crashed before we could activity monitor it. So I'd like to do that really quick. I just want to see what we are sitting at here. Because we were formerly sitting at 40% of a core, and now we've doubled that, right? And that's not really such a bad thing. We kind of do want to be using up a lot, but I think we may have a problem here when we hit 100. I think if we hit 100, then we'll start to have problems, because at least all of my code is still single-threaded. So I do not anticipate things really playing nicely once we hit that point. Anyway, so we have some more stuff to try to figure out here. Unfortunately, this did not. Oh, and look, it crashed again. Oh wow. Or something happened. It's still running pretty crappy looking. It still looks like it's basically at 15 frames per second. and it does appear like these go-to renders are popping up, but I think I just need to time those because we're still kind of guessing a little bit. But this, and I have not found a way to better profile like CPU stuff. Let's actually just look that up. Xcode CPU profiler. Aha. Product profile processor trace. Let's do that. That would be good, right? So we probably are gonna have to come up with our scheme here. We will do our game.app app. Instruments, let's try CPU profiler. I don't have any arguments we really care about. Okay, so should we try that? Oh. Okay. It's actually kind of weird. I haven't seen this window pop up without the metal GUI in a while. It's kind of funny. All right. Let's see. Now, the problem is, like, does this have the symbols? Oh, it does have enough symbols, it seems, to do stuff here. So we are in this p thread. Okay, kind of looks like that one is maybe not it. This dispatch. Oh god, I'm just trying to find the thing, dude. Oh, here we go. Here we go. Metal view delegate render loop is of course our biggest thing. But 40% of the time we are spending in game loop, which makes sense because we kind of are asking it to, we kind of are forcing the control flow into there a whole bunch. Oh wow, we spend a lot of time just normalizing vectors, don't we? And multiplying vectors. Interesting. Anyway, yeah, I would think our I would think for the most part the stuff we're doing in the render pipeline part of the loop is not going to be as expensive because most of the resources we already have sort of course it's another thing where I can't zoom in, but most of the resources we already have allocated and are we're just kind of like doing a copy. I think the expensive part I would have thought would have been constructing our V buffer out of the quad buffer, but maybe not. This next drawable call this is like one creepy thing where it is this is probably what is still like sometimes enforcing vsync or doing something stupid. Yeah, so it does eat some real time for garbage collector to do stuff, but that's just the way the cookie crumbles. Platform mem move. Yeah, that looks like our I need to remind myself of that part of the routine here. Because I would have thought this would be the problem, was we go into this alloc, um, loop through all the quad. Well, I guess it is that there's not that many quads right now. That very well could be it. And like maybe, hey, possibly the compiler has found something nice to do with this to SIMD all of these each of these vertexes per quad to make it nice. How's it going, Killy Killy? Good to see you again. We're doing some fun work here. Trying to debug a little bit of a unfortunate problem with our rendering setup. We've got the game kind of running on Mac here, but I'm trying to decouple the physics simulation speed from the display frame rate because it's just the game just performs so differently from monitor to monitor with different refresh rates. Oh yeah, now I'm back from my holiday. It was good. And this is what I got to this far on several plane rides worth of working. But as you can see, like even though like the Metal thinks we're drawing frames at like almost 300 FPS pretty consistently, well at least 200. Like it looks really shitty. It looks like we're drawing at some like fraction of that, like around 15 FPS or something. Yeah, minor setback here. And I've been trying to figure out why for the last couple of days. And I guess that we need to fix the escape flow at some point. Seems to be broken again. But basically every one of these go-to render logs I'm putting out here is when the physics simulation part of the game loop has said that it hasn't accumulated enough time yet to actually run any physics sim. So we're trying to run the physics at like 480 hertz. And we're trying to draw, as fast as we can. So, which was targeting like around 180, 200, so on. So and then these logs are every time we actually do a physics sim step. So what I would have expected to happen is basically we get 2 of these per every go-to render. But there's like 30 of these or so per go-to render. And what I think is happening is, basically we are, because we're simming apparently at 1/32 the rate of the amount of times like the draw call is being made. I think we just have stale vertex data that we're passing out to the GPU 32 frames in a row, and that means that our effective FPS is cut from 180 divided by 32. It's cut to like 5 or cut to like 11, which kind of looks like what's happening. But the problem was we're using some Metal API that kind of was doing vsync for us. I ripped that out and have it just going as fast as possible now. But it still seems like there is some vsyncing going on. Like we're hitting some limits around the refresh rate of my monitor. The physics display rate still seems pretty slow. So I'm just like looking through. We're trying to profile like our CPU loop right now to see like what the heck is actually happening. And it kind of all just like looks a lot like what we expect it to look like, which is good. It does look like most of the expensive stuff is like in there. what else actually uses a lot of our CPU time? In NS application run, so there is, I guess, a significant amount of time being spent in event handling by NS application. So it's, this is for tracking like mouse movements and keyboard stuff. It's kind of higher than I expected, but oh well. Yeah, and then there's just like some message looping crap going on. That's fine. We kind of that I don't think we have as much control over right now. So that just has to happen. Okay, so I think we've kind of run out of things we can get out of here, but it's good we know how to get to this profiler here again. That's good. So I think, no, I don't want to save the trace. I think what I want to do is I want to add some more timing information to this log here because like, we're kind of just still going qualitatively off of like, yeah, there's this many logs of this type to this many logs of that type. Because it's possible there's still something wrong with my logic of how I am choosing to batch physics sims over like render sims, basically. So how do we want to do this? Well, I think it would be nice, actually. The places that we care about is we actually care out here in this outer loop that is controlled, that the metal view delegate is running. This is being run by global dispatch queue, which I think is the thing you want to tell macOS to just like keep running the thing as fast as possible. I think like in its own thread, basically. Yeah, and I think that's what we want. What are the flags we would want here? Reserved for future use. Oh, okay. So we don't want that. Okay, you know what? Yeah, I think we just leave that for now. Might be a problem. We have more control over here for right now. So I think what we want to do is at like the top of the loop here, we'll just do like a stupid like render frame start. I have that in the wrong spot. Okay. Yeah, so, most of the time we skip through it, and we're only doing like one physics sim per thing. So we want to, we actually want to be going and grabbing the time at all of these points too. So let's do that. And then in a string, is there like a nice way for me to do that? %at, okay. Okay, well, I just have to make it like that. Oh well. Why doesn't it like that? Oh, yeah, we can do that. Could I have just done that there? Okay, we can just do that there. Okay, and then we do, like /t, dt equals. Okay, so we do one of those. In auto release pool. Yeah, we actually should probably keep that in auto release pool. Minus time lasts. Yeah, that might not be great, but we'll just see how that looks for now. Okay, so yeah, what are we looking at here? We are seeing that 1499.419800. So that's like our elapsed seconds since the OS booted. Just like 25 minutes. Maybe that makes sense. Maybe that makes sense. But our DT, yes, still not really working, maybe. Yeah, I don't know why we can never get this to print out like this delta time value correctly ever. Which is a little, that could be a problem, right? That very well could be a problem. Because what should time last be here? It should actually be still like the previous frames DT, right? Because we're not changing it, or the previous frames new time at the start of the sim loop. Okay. Let's just step in here and see what kind of values we're actually getting out for it. So it's a little crappy. So new time 1503. World time last 1503.14.146. Yeah, that. I think I'm just like I'm probably still doing something stupid here, where this is not right. Um. It always seems like this value's wrong. So let's see. So here, oh, at the very start of time, why is dt that? That doesn't make any sense, right? Time last should be the same as the start time there in game init. Oh, you know what? It's because we haven't set up the world yet. So it is going to be 0 initialized. Yeah. Okay. Now that's correct. Oh. 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 Oh, I see. Yeah, that might have to also be here. That might have to also be there. Oh, what the hell? Okay, so let's take a look at that. It's a little weird. The very first time we logged this, it should look like that. Render frame start. DT is that. Yeah, because I think we expect like the very first frame, we are hitting that clamp top condition, and then we're just doing a quarter second. So that's for like when we debug, we don't want it to sim any sort of like gigantic frames in between. So render frame end. Okay, whatever. Render frame ended right there. And then it took this long or that long to get back in. 0.095. Just 95 milliseconds. Wait, 95 milliseconds is a lot. That's a lot. Because our frame interval is like 6. Is that right? let's see. Because we're trying to draw these all in seconds. That is, that's like a crazy amount. Because our target is this, right? We're targeting like 2 milliseconds here. So that's why here, we saw so many sim frames accumulate. But then, after we get to stable here, then we're not accumulating like any time. So after we load, then it kind of looks, we're back in this state here where it looks like, just not enough is happening. Curiouser and curiouser. Come on. Oh look, this one picked up like a DT here. But that wasn't enough to actually hit a sim step. So what is the problem? What is the problem? So if we actually just do the math here, the start of this frame was at 813. 813,599 minus 813,721. Okay, so that took 122 milliseconds. 122 milliseconds means that I should have I should have simmed 64 frames in that time, right? Yeah, so this is still wrong. I think it might just be the control flow. It might just be the control flow is still screwed up here. Okay, well that's fixable. So let's not worry about that part. The problem would be in here. We're getting our elapsed seconds. And it does seem like they are precise enough to 5 decimal places, where we can get something out of it. I think I had some problems if I was not clamping the top of this thing. I would like to confirm that's the case. How is it possible we get like kind of 2 frames within the same OS seconds call? We get like multiple of those calls Um, yeah, there's something like really stupid going on here. By really stupid, I mean really stupid. Auto's not really helpful ever. Okay. So, yeah, new time is that. Time last is that one. While accumulator is bigger than SimStep. And where is our trusty accumulator here? Um, is that static not working? Is that not working the way I think it's working? It's very possible. Yeah, so this is a spot where the delta t should be non-zero. Was non-zero. Um, but then we do this retiming. We do timing first here, and then we do timing again in here because of this OS update call, right? So that we can be getting our keyboard input many times per render frame. This is possibly the problem. Where I would like to see where accumulator is here. Accumulator is a number. Yeah, it's a number and it hasn't yeah, it had some crap in it from before we hit that point. So this should, yeah, this is now about one physics step. So it should actually get in here. So we should see delta t get clamped to 0.25 here. Yes. There plus equals minimal delta t. So let's think, like, why would this be a problem? Why would this not be working? Um, I mean, like, this should probably just be a do while here now. Because we always want to run that the first time, I think. Alright, because once we get to that point, then, we're down here. Accumulator minus equals, no, some step. Alright, yeah, you know what? I think the answer is just timing out the wazoo still. So let's just do that. Sorry if this is a really lame stream. Some days it's just a really lame problem. So we want to stick one up here. Don't really care about that one. All right. What I don't get is this is so that no, that's like less than one. I mean, is the problem now basically that like we're like because we're calling so fast, the like we're rendering faster or trying to render faster than we can keep up. Faster than 480 hertz, right? And it's just like fundamentally not going to work like that. Um, this is like the last thing where there is something else that is controlling like the VSync timing, I think. Alright, you know what? We can do this, set this max drawable count, I guess. I don't think that's really going to help that much. But I think it's something that it wants us to do. And what's that going to do? That's going to make it so there's 3 different buffers for us to be writing into. You know, we're still kind of seeing it takes a while to actually get to a big enough accumulator that we do a physics and then we update the draw frame, right? Alright, what else is in here? And we're gonna have to cut the stream off in a second because I've gotta go run to work very quickly. Yeah. Alright, well, I think this is going to take some more thinking to fight with the way Metal wants us to do stuff, the way we want to do stuff here. Thank you very much for joining me today. That's the end. That's the end of the stream. Unfortunate, but you know, this is now kind of in the weeds here of our fun Mac stuff. So come back next time, and we will hopefully have made a little bit more progress. I'll keep working this, you know, throughout the rest of the day here. Yeah. Have a good day, everybody.